So we are going to take a look at the definitions and the language of parabolas. So here are some definitions. You may want to pause as I'm going to go through these fairly quickly. The vertex. The vertex is a turning point of the parabola. It is the point upon which the parabola either goes to be from a decreasing function into an increasing function, or alternatively from an increasing function to a decreasing function. Since it's a point, our notation here has to be a point. The vertex happens at HK. Notice how it's written as a point. The Y-intercept. The Y-intercept is the Y value where a relation crosses the Y-axis. How we note a Y-intercept is just really the Y value. So we put Y-int colon blank. Please note that it's not Y is equal to some value like 4, because you and I both know that that's a horizontal line. That's not what we're trying to do. We're just trying to communicate the Y value that where it crosses. The X-intercept. Now the X-intercept is really the X values where the relation crosses the X-axis. And typically, in similar fashion, we have X-intercept colon, and we simply list these. Please be careful that if you're trying to say there's two zeros, like 0 and 2, don't do this, because as soon as you put brackets around it, you've indicated that it is now a point. It is more a description of the X values of a function, or the X values of where the relation crosses the X-axis. Zeros. Now, zeros and X-intercepts are often used interchangeably, but zeros are sort of a more application type language. It is the location, or the X values, where the function has a value of 0. That is, where is f of x equal to 0? Well, this happens at our X-intercepts. Again, like X-intercepts, we list them. So we say zeros at, and we list 2 points. Sorry, zeros at, and we list 2 values, or 1 value, or no value. The axis of symmetry. This might be new. It is the vertical line about which the graph is a mirror image of itself. Is there a vertical line that you can graph, or that you could draw, that cuts a parabola in half? I'm going to say yes. And that's always through the vertex. Now, vertical lines have the notation x is equal to. And as we'll see, all the axis of symmetry have to go through the vertex. So the equation of the axis of symmetry will be x is equal to h. The direction of opening isn't that big of a deal. If we've seen this before, as a is less than 0, our graph opens downward. If a is greater than 0, it opens upwards. Now, maxima or minima. So this is kind of interesting. The minimum is the lowest defined y value. So we say minimum at, and we give the value where it's minimum. So it's defined. The maximum at. So the maximum is highest defined y value. Let's go up to here and label our graphs, shall we? So I'm just going to list, I believe the first one was vertex. My vertex here, I'm going to just label it just to help me out, is going to be 1, negative 2. So I have to label my vertex 1, negative 2. My y-intercept. My y-intercept for this graph is 0. This is the point I'm talking about. It's 0. My x-intercept, well, we have 2 of them, 0 and 2. Notice how I'm not putting brackets, because all of a sudden that turns into wrong. Now, my zeros. My zeros are going to be the same, 0 and 2, or zeros at 0, 2. It's all good. My axis of symmetry. Now, this is a brand new idea, and it's going to help me out tremendously here. My axis of symmetry. So what is the equation of this blue line? Well, we know that all vertical lines are in the form x is equal to. So here, it's going to be x is equal to 1. Last but not least, what is the maximum or minimum? Well, I'm just going to put minimum. Minimum at here, right? Minimum at -2. That is the lowest y value. What is the maximum? There is no maximum here. This graph goes up and up and up forever, so there is no defined maximum. All right, let's go to the second graph. I'm going to write vertex. My vertex on this graph looks like it is 1, 3. So it's almost the same as the other one, but not. My y-intercept, if you recall, is 7/2. You could put 3.5, and that is acceptable. But just be careful. You have to be flexible with the way you think of numbers. My x-intercepts. There is none. There is no x-intercepts, and that's kind of an interesting concept. My zeros. This function never is 0. There are none. There are no x-intercepts. My axis of symmetry is this line right here. What is the equation of that line? Well, that cuts it in half. The equation of that line is x is equal to 1. Last but not least, this graph. Does it have a maximum? No, this graph goes up and up and forever. So it doesn't have a defined maximum, but it has a minimum. So we would say minimum at, and we take a look at that y value right there. We know the vertex happens at 1, 3, so we would have a minimum at 3.